Good evening, Dr. Andrew Merrill here at Nightlight Chiropractic in downtown Orlando. And this is our video that we do each week called Wednesday Night Wellness Live, where we give you, the viewer, a little bit of knowledge that we are seeing here in the office on a week-to-week, day-to-day basis. And we try to make it interesting for you. So if you're watching us, feel free to comment and share and like, and I'll be happy to play along and try and answer some questions. So tonight, I've got a really important video for a lot of you, I think, but I need to start with a couple of announcements real quick and go over some of the stuff that I think we need to talk about real briefly. So one of those things is I'm happy to provide telemedicine to you, my patients, my viewers, my friends, at absolutely no charge. You know, if you need to reach out to me, drmerrill@nightlightchiropractic.com gets you to me. If you give me a telephone number, I will happily call you and talk to you about what's going on or maybe what we can do or what you can do. I'm not going to charge you for that. I'm not going to try and work with your insurer to figure out how to bill that. I'm happy to give you 5 minutes of my time to make sure that you have the answers that you need. Keep in mind, I'm a chiropractor. I need my hands on you to do things that are going to help to fix you. So I can only do so much, which is why I'm happy to provide that service to you for free. So the second thing, and this just came down the pipeline the other day, is after an auto accident, there's this law in Florida. If you're here in Florida, there's this law that after an auto accident, you only have 14 days to seek care with your auto insurer, and that still applies. So even though we have this worldwide pandemic, it is really important that you get checked within 14 days, whether it's a medical doctor, a chiropractor, a Centricare, whatever it is, you have to get care within the first 14 days. And then one of the other things that I can't do this video without mentioning is that we're starting to hear from a lot of our patients, our friends, our families, that there's been some coronavirus deaths. There has been families that are truly impacted now. My heart goes out to you. My prayers are with you. I hope that you can make it through this tough time. If you ever need me for anything, please don't hesitate to reach out. Okay? So the catalyst for tonight's video, which is a little bit different, if you see this behind me, this isn't my normal backdrop, actually came from my son. So I've got two small sons. They're 6 and 8. And they asked me the other day while they were doing homework at the dining room table, they said, "Dad, how does this work exactly? What is a virus?" So I started kind of trying to explain to them what a virus was from the ground up. You know, I mean, these guys have no idea because they were under the impression, and I think some of you might be too, that when you're washing your hands, you're washing the virus down the sink. Did anybody else think that out there? Be honest. So that all kind of started this whole cascade of me drawing on paper and kind of showing them, here's how a cell works, here's how a virus works, here's kind of how they go together, and here's why it matters to you to do some of the stuff that we're talking about doing, which is socially distancing, which is staying in your homes, which is washing your hands. These things are really important. And the latest, like we talked about last week, mouth coverings. When you're out and about, mouth coverings. And we'll talk about some of that here too in just a minute on this fancy backdrop that I made myself. These drawings are amazing, I think. But it all started at my dining room table with my 6 and 8-year-old when I'm trying to explain to them stuff, and I took a little piece of their paper and I just started scratching out stuff, and it made sense to them. So I think it's going to make sense to you because we've been told how, right? We've been told here's what you do, but what we haven't really been told is why. Why does this work? You know, I haven't studied biochemistry, maybe ever. So what are we talking about in real time? The reasons for why we're doing this. And we're going to jump right into that with this picture behind me. So bear with me while I try and get this camera set up so that I don't have huge technical difficulties. Hold on one second. How's everyone doing out there? I'm seeing some people watching me. You're watching. I see no comments yet, but there will be because this is good information, I like to think. Let me see if I can get you all set up here. Okay, I think we can start to see everything that I have drawn here, and my staff graciously let me into my markers today, which they had kind of taken away for a while because I can't be trusted. But we're going to run right through this here and understand that my numbers are backwards for you, but I did learn how to draw COVID backwards for you like I was in a mirror. So, and I'm still right here. So I'm seeing your comments. If you have comments, don't hesitate to reach out to me. So we're going to start with 1, and number 1 is your cell, right? So this is your cell that I drew up for you here. It's got your DNA on the inside. These 2 lines put together is your DNA. And then right around the edges here, you have your lipid bilayer, right? And this is your cell's way of keeping the cell inside and everything else outside, right? So yeah, art class, exactly. So what we're trying to do, the cell wants to make sure that it maintains itself, and in doing so, it creates this lipid bilayer that prevents stuff from getting out and stuff from getting in. So your cell replicates by taking this DNA, splitting it into something called RNA. So if you know anything about DNA, DNA is this big long chain of amino acids that then get together with other amino acids that kind of match it, and they basically hold all of your cellular information in them. And it's important because then your body uses that cellular information to split into RNA to then go make the next cell. So if you see down here, I've got the next cell drawn up, and there's some other stuff going on here, but a normal chain reaction here, or a normal splitting of a cell, is your body uses RNA to make new proteins to make a new cell. Let me know if I lose anybody. Please stop me dead in my tracks if I lose anybody, because I'm trying to keep this with just like an overview of everything. So that's the way a normal cell replication happens. So then along comes this COVID-19, right? And this is not drawn to scale. This is not even close. Some of this artwork doesn't even really depict what's going on, but this is a simple way to understand what's going on. So this COVID-19 virus, this coronavirus, is not living. It's not like the rest of your cell. It's not like your cells in your body. Your DNA is put together with like 3 billion base pairs. It's huge. It's this huge long genetic code. What's going on here in this coronavirus is actually RNA. So it's traveling around as RNA, not as DNA. And this RNA is only about 30,000 base pairs long. It's not the 3 billion like we have. It's a teeny tiny little snippet of code. But understand, viruses aren't technically alive. So without our cells or some other mammal cells, this would never go anywhere, right? It would just kind of wither up and die after a certain amount of hours or days. It can't propagate and make more virus without your cell. So let's talk about that real quick. So you have this coronavirus or COVID-19 virus RNA, and what this coronavirus does is it attaches to that lipid bilayer that we just talked about. So it uses this little spiky points there, its little points to then grab on or latch on to your lipid bilayer, and then it fuses with the cell, and when it fuses with the cell, it gets to inject its RNA into your DNA. Right? So then you have this strand of virus RNA that's latched on to your DNA. And then what it starts doing, this is where it gets kind of crazy, right? So this thing that's not even alive has now tricked your cell into start making more of them. So you see down here at my bottom, you end up pumping out, this cell ends up pumping out millions of these virions that then go on to find other cells to then continue this process. And that's really important because it takes your cells for this to happen, right? So this is never going to happen without your cells. Understand that this virus is not living. It's not trying to attack you. It's not coming to get us. This is the only way that it can survive and keep propagating. So one of the sneakier parts here, and the reason that this can happen en masse and why it's dangerous to us, once that virion, once that virus attaches to your cell, it basically tricks your immune system, right? It tricks your immune system into thinking, one, there's nothing wrong, so there's no reason to attack, and then two, it kind of starts pumping out proteins so that you end up with a different kind of cellular layer so that it can continue to pump out as many of these virions as it can in such a short amount of time. Now, eventually your immune system wakes up. Your immune system realizes what's going on, and it starts attacking these different cells that are pumping out these viruses for it. The problem is that if there's a huge viral load, meaning you get a lot of this stuff all at one time, you end up with too many cells making too much before your immune system catches on. And then the other thing that ends up happening is your immune system starts to overreact. So when your immune system overreacts, what you end up getting is this huge conglomerate, this huge mass of dying cells, and then in turn you end up with a lot of fluid. And when that fluid is in your lungs, you end up unable to breathe, right? And so when you're unable to breathe, you get put onto a ventilator, and then hopefully that ventilator is enough to keep you breathing long enough so that your immune system can do the trick. Right now, we don't have anything that stops this process exactly, but we're going to talk about some of the things that are out there right now. So I've got a question here. I've heard people say this virus stays alive on surface for 2 weeks, true or false? Well, actually, I'm reading a lot about that, and it depends on the surface and the temperature and the humidity, and there's just too many what ifs. Like, even if they figured it all out exactly in a lab, in real time, you never know, right? So you have to just assume that it's almost everywhere that you're touching, right? I would just go with that. Just assume that it is literally everywhere. And then what are we going to do about it? We're going to follow the how. So how do some of these things, how how do they play out in real time? So we talk about social distancing, right? Social distancing was the first thing that we started doing. And why did we start the social distancing? Because if you're never around someone to get the first one of these into your body, then it doesn't matter. Like we said before, it's never going to affect you if it never gets to you. So social distancing, keep this stuff away, because if the last of these dies on the whatever host it's on, so the last person to have COVID-19 ends up staying away from everybody else, that's the end of it. There's no more of this virus. It's gone. Certainly viruses mutate and turn into other things, but that's a whole different story. We're worried about this COVID-19 for right now. So kind of what started this whole thing, well, why do we wash our hands? So I didn't talk about this before, but this virion, this virus, is not quite put together like our cells, right? It doesn't have exactly this lipid bilayer, but it does have a lipid layer. So on the outside of this blue line that I drew is actually a fat layer. And so when you're washing your hands, when you're getting a nice good lather of 20 seconds worth of hand washing done, what you get is that soap destroys that lipid layer and lets loose all of that RNA, so it's ineffective and can't get to you. So you want to wash your hands not to wash this virus down the sink. You want to wash your hands so that that thing gets cracked open and is dead and done, and it cannot get to any other cells, okay? So that's really important. That's why we're washing our hands. So lastly, I want to talk to you about some of the other things that are kind of on the horizon here and moving forward. Because I think we're making a little bit too much, we're putting a little too much stock into some of these things, and I want you to understand kind of their limits, okay? So one of these things is a vaccine. Do we have a vaccine for this thing yet? And the answer is no, they're working on it. In fact, there are so many groups working on a vaccine for this. It's amazing, it's exciting, it's going to change medicine probably forever in such a great way to know that all these different groups can come together and work together. But right now, we do not have a vaccine for this. But what a vaccine does, you see these little blue moons that I drew up here? So those blue moons are actually antibodies. So if you were to get a vaccine for this, your body would develop antibodies. Actually, if you end up catching this and getting well from this, your body will develop its own antibodies, and those antibodies stick on to those little spiky boys, those little spiky points, and they inactivate that virus so that it cannot attach to the cell and do its magic, right? So if we're getting vaccines, if and when we get vaccines for this, and we will, it's just a matter of time, it's going to inactivate those, so it'll be important to get vaccinated for this in time. So there's another thing that is kind of on the cusp of this, which is the hydroxychloroquine, right? Hydroxychloroquine actually interferes with the chemical environment of the cell membrane. So we have to go back over here real quick. That hydroxychloroquine actually interferes with how the chemistry happens at this lipid bilayer to prevent that COVID-19, that virus, from attaching well and then kind of fusing itself onto your cell. So that's how that hydroxychloroquine works, although there's a lot of research out there that's conflicting, right? Some studies say it works great, some studies say it doesn't work at all, some studies don't have a control group, and you know, if you've listened to me talk ever, it's important to have a control group. If you don't have a control group, it's hard to know what's doing what. So I would hold off on going crazy about that stuff right now. I just explained to you why social distancing and hand washing absolutely works, and we're not going to need a control group to prove that. What we need you guys to do is all follow it, listen to it, do it. That's all I have for this evening, unless you guys have any questions. I know that this is kind of the cursory overview, and I want it to be exactly that because we never get this, right? You don't ever get this explained to you. What you get is like the crazy technobabble that doesn't really make much sense. So I hope that this has been beneficial to you a little bit. If you wanted to show it to your kids to help them understand why we're doing it, I would love for your kids to see this just like my kids did, because they got this. They understood, they were complaining about having to stay inside, but they understood that this is how it works kind of at a deeper level, and it made sense to them. So anyways, that's all I have for the evening. If you have more fact and fiction questions, I'm happy to look at the research. I'm looking at the research anyways, so if I can get the answer back to you in a timely fashion, just let me know. I'm happy to do it. But anyways, that's it for this evening. Have a wonderful rest of your week. Happy quarantining. Wash your hands. I'll see you next week for another Wednesday Night Wellness Live. Good night.